but you know, it kind of spells example, right? Egg, E-E-G, example. Yeah. That's how you spell it, isn't it? Okay. So anyhow, for example, I'm not going to do all the problems because the problem is to make tables and construct graphs for all the basic functions. Okay? And your table, as you know, starts out with x values -2, -1, -1/2, 0, 1/2, 1, and 2. Okay? Do y equals 2. Now, I'm going to, the one I get even more errors on, it's like y equals 1 over x. Maybe it's 1 over x squared. They act fairly similar. You get y values -1/2, -1, 2. Undefined. You don't get any apples on any day. How long does it take you to get 10 apples? No answer. Okay? You never get them. Improperly posed question, it's undefined. Okay, 1, 1/2. And then you sketch the graph. And I'm not going to, go to the trouble of clearly labeling the points, but you go from -2 to 2. And in this case, you go from -2 to 2. If it was 1 over x squared, you'd have to go from -4 to 4, but you wouldn't really need the negative numbers because 1 over x squared is always positive. You at least got to go up to 4 here, because 2 squared is 4, and so is -2 squared, right? And you get your points. So you get a point like this, and a point like this, and a point like this. And I think everybody's okay with sketching these points. Okay, then you sketch your curve, but you don't try to make this curve cross x equals 0. You get vertical asymptotes. Because the closer x gets to 0, the bigger y gets, and there's no limit to how big it can be. If you take something smaller and smaller and smaller and divide it into 10 or whatever, you're going to get bigger and bigger results, and there's no limit to how big they get. That makes the graph approach the y-axis as an asymptote, both here and here. So vertical asymptotes here and here. And curve doesn't cross the x-axis because x equals 0 isn't in the domain. Expected to know that. Spent some time talking about it. And if everybody was reviewing at least the board pictures, you'd more likely be reminded of this, okay? And since approximately 25% of the class seems to be reviewing on the average, it concerns me. If you're not reviewing, you're not going to remember things. You're not going to pick up on things. You're not going to catch things. You will have heard them in class. You have kind of understood them. You look at at least the board pictures, and it reminds you, puts this on your map while it's still there, before it gets away from you and you don't remember ever having seen it before. Okay? And then hopefully you go back to the videos, which are kind of long, but you can flip through them and find what you're looking for if you have an idea that you need to see. Okay? And there we have it. You need to be doing that. You will do better if you've been doing that on the test than you would have if you hadn't. Okay? Okay, so anyhow, there's number 1. Okay, number 2. Now that's just one function. You need to know that you don't include the -1/2 and 1/2 for the 2 to the x function. Not that they're undefined, it's just that you don't know what those numbers are. Okay? And all this is done by using the arithmetic you know, not a calculator, to evaluate these things. Okay? Okay, on number 2, state and explain the domain and range of each basic function, right? Okay? For y equals x squared, the domain is well, I said for each basic function. The domain for the basic function consists of -2, -1, -1/2, 0, 1/2, 1, 2, because the basic function, as we've discussed, is just the points you get when you do your table. Okay? And the range is 0, 1/4, 1, 4. Those are the values that you get. If you look at the table for y equals x squared, which you ought to know in your head by now, that was the easiest one probably, you see that those are the only numbers that appear. And you don't repeat them just because they repeat on your table. This is a set. If it's in the set, it's in the set. If 1/4 is in the set twice, 1/4 is just plain in the set. Okay? Now this is the basic function. What I call extended, and you need to know this terminology. It's not standard terminology, but it's actually not going to write it as a set. We're going to write it as an interval, and it includes -2. It's -2, 2. All the numbers from -2 to 2 are in the range, a domain. So the range is the set. It's the interval 0 to 4. On the x squared graph, all the y values from 0 to 4 occur. There are points on the graph for every number between 0 and 4, right? Okay? And that's what you get when you connect it with the curve, and it becomes obvious why. Okay? The domain for complete is what I started to write down, -infinity, infinity. There's no number that you can't square. And when you square numbers, you can see what's going to happen with the graph. It starts out like this, and it's just going to keep getting steeper. It's going to follow the pattern. And you see that all possible y values from 0 to infinity occur. Now, there are algebraic ways to prove the same thing. But there you have it. Okay? Now for y equals x cubed, I'm going to just kind of list these. I'm going to say a few things, but again, -2, -1, -1/2, 0, 1/2, 1, 2. The range is -8, -1, -1/8, 0, 1/8, 1, 8. Okay? The extended function is from -2 to 2. I'm just following the same pattern, basic, extended, complete, right? And the range would be from -8 to 8. The graph makes it clear that you can just connect these points. You get a graph that looks like this. And every y value from -8 to 8 has an x value. Okay? And then -infinity to infinity. And it's clear just visually extending the graph, and we'll worry about the algebraic proof later, that as you would probably expect, the range is -infinity to infinity. Okay? Y equals 1 over x. The domain is -2, -1, -1/2 for the basic function, then 1/2, 1, 2. You don't have 0 for the reasons I mentioned over here. If you think you can get 10 apples by getting no apples a day, you have a problem. Now, if you don't connect that with the range of the function, it means you haven't thought through it deeply enough, and you don't really necessarily have a serious mental problem. You just have a little bit of a mathematical problem, which is not as bad, okay? Now, if you really think you can get apples by not getting apples, you're at least logically challenged. Probably, maybe don't need to be institutionalized, but you need a little help, okay? Well, that doesn't apply to anybody, and I'm just joking about it, of course, if some people do have perfectly good mental capabilities, but they got this quantitative block. And they really think they can get apples by not getting apples. Okay, anyhow, 1 over x. And the range is a set. -2, -1/2. Well, let's do it in order. -1, -1/2, 1/2, 1, 2. The same numbers appear over here as appear here. Just coincidentally, but not, they don't correspond to each other, right? The -2 corresponds to -1/2 and so forth. Okay, well, your domain is -2, 0, union, 0, 2. All the numbers from -2 to 0, and all the numbers from 0 to 2, but you don't get to include 0. This is, in other words, this interval, you have to exclude 0, and this is how you notate it, okay? And the range is also -2, 0, union, 0, 2. And I did it wrong. Started to do it right. Since I've done this one wrong, I did that one wrong. Okay? And you have the open bracket, or the open parenthesis here because you don't include 0. Close parenthesis here because you do include -2 and you include 2. Okay? And then for the extended function, -infinity to 0, union 0 to infinity. Once more, you don't include 0, so use the open parenthesis. And infinity is beyond any number, so you can't include it. It's not a number, okay? But it's all numbers up to infinity. In other words, all the numbers there are as you approach infinity. And your range is also -infinity, 0, union, 0, infinity. Okay? Now number 2, put it on domain, range. The 1 over x squared function, your domain, is again -2, -1, -1/2, 1/2, 1, 2. Your range is -1/4, -1, -1/2, 1/2, 1, 1/4. Well, it's not 1/2, it's 1/4. And okay, more sensible way of listing it. -4, -1, -1/4, 1/4, 1/4, which are the numbers that you're going to see over here, but not in that order. Okay? Again, and when you list a set, the order of the numbers doesn't matter. So you usually want to order them from least to greatest, not the order in which they would appear on the table. Table, of course, the order really matters for obvious reasons. Okay? And again, the domain, you can square any number except 0. And when you do that, you can get any number except 0. Okay, so that's for the extended. Now, that's for the complete function. The extended function, I didn't write it down, but it should be obvious what it is. Okay, so then we have 2 to the x. Your domain for the basic function, remember, consists only those numbers in the set, well, from -2 to 2, you know, the subset of this at which you can actually evaluate the function and write down the result as a whole number or fraction, okay? Or as an integer or fraction. So we don't include -1/2 or 1/2. You can't calculate that. If you can't calculate it, we don't do it, okay? And since calculating it would take forever, since there's no end to the decimal places and the calculation process is way beyond what we do in this course, okay? We don't calculate it. Your calculator can't calculate it either. You can calculate it to 14 decimal places or whatever. You can't calculate the whole thing because it's infinitely long. Okay, so anyhow, you have this. Your range is then the set 1/4, 1, 0. Well, let's do it in order. It's not 1/4, it's 1/2. And I'm not only smudging this up, I'm writing down wrong numbers. It's 1/4, 0, start with 0. 1/4, 1/2, 1, 2, 4. Those are the numbers you get when you make the table. Okay? I'll get it right eventually. Okay. The extended function is again a whole interval -2 to 2. There's no number you can't put in for the exponent and get a result. Of course, you got to remember 2 to 0 is not 0, it's 1, which means that I shouldn't have put 0 in there. Can't get 0. Okay? Okay, so 2 to 0 is undefined. And there's no number that you put in here that gives you 0. Because of 2 to the -x being 1/2 to the x, there's nothing you can divide into 1 that gives you 0. Okay? So, excuse me for messing that up. Okay, -2 to 2, then you have all the numbers from 1/4 to 4. The extended function. Okay? And complete. Your domain's -infinity, infinity. You can do 2 to the x for any number. 2 to the x can't be 0, but it can be any other positive number. So your range is the open set from 0 to infinity. You don't include 0, because again, you get close to 0 with a negative exponent, as you can see from the fact that 2 to the -2 is 1/4, right? So 2 to the -3 would be 1/8, and so forth. But you're never going to get to 0, because there's no exponent that makes 2 big enough to divide into 1 and give you a 0. You can't divide anything into 1 and get 0. Okay. So there's your 2 to the x. And you got the x squared, the x cubed, the 1/x. And that's all of them. And those are the 5 basic ones we've talked about. Okay? So, you got to know that. It's not hard. If you started making the tables when I told you to start making the tables, you've understood pretty much all of this all along. If you made some mistakes, you didn't know the laws of exponents, didn't know you can't divide by 0, well, would have taken an extra class to get that right. Okay? Now, knowing to put it in this form, you don't necessarily have to present it in this form because the question asks well, it asks you to do all three, and it doesn't say how to do it. So you do all the basic functions, then you could do all the extended functions, then you could do all the complete functions, right? So I don't care if you do the x squared, do the basic, extended, and complete, and follow the same pattern, or do all the basics, then all the extended, then all the complete. Probably easier to do it this way, but that's up to you. Did I see it all? And there's no reason anybody should miss any of that, except by carelessness, which can happen. More or less forgivable as long as it doesn't happen too often, right? You're going to get penalized. And, you know, if you think you can divide by 0, that's a heavier penalty than just doing an arithmetic error. Okay? Make sense?